In the last part of this lecture, I want you to work a problem based on some estimates of your own problem. So the first thing I want you to do in approaching is estimate your own weekly consumption of gasoline in gallons. This doesn't have to be very accurate, just a rough estimate. So for example, if you have a car that has a 15-gallon tank and you fill it every week, then it's 15 gallons in a week. If you have a car that has a 15-gallon tank and you fill it every 3 weeks, it's 5 gallons per week. But again, it doesn't have to be very accurate, just a rough estimate. If you don't drive, just ask somebody who does. Use their numbers. First thing I want you to do is find the energy content of this gasoline in kilojoule units. And in doing that, we can use the information from the last problem on part 3 of this lecture. So when we use that information, here's the calculation we did. We used octane as a representative of gasoline. And we said 1 gallon of octane. We went through this calculation, converted it to milliliters, convert the milliliters to grams using the density, convert the grams to moles using the molecular weight, and convert the moles to kilojoules using the heat of combustion. And we got this number, 127,500 kilojoules, or 1.27 times 10 to the 8th joules. Now, we can use this. We don't have to repeat this calculation. Let's just use this equivalence. We can have an equivalence between 1 gallon of gasoline and 127,500 kilojoules. And that equivalence gives us a conversion. So simply take however many gallons you use in a week, multiply by 127,500 kilojoules to get the number of kilojoules of gasoline the number of kilojoules of gasoline energy that you use in a week driving. Now, is this number greater than or less than or approximately equal to the amount of energy that you consume in food? And I presume that it's going to be much greater unless you hardly drive at all. So let's look at that. We want to compare that number to the energy you consume in food. So estimate your daily consumption in food calories. And just remember that whatever number you come up with is really equal to what chemists call the kilocalorie, not the calorie. So for instance, if it's 3,000 calories, we call that's really 3,000 kilocalories. And then we want to take that number and convert it to kilojoules, so we can compare with the number from the gasoline. And then we want to put it on the same basis and multiply by 7 for weekly consumption, because this is daily. That calculation is illustrated here. However many calories or kilocalories you eat in a day, use this conversion to convert it to kilocalories to kilojoules, and then we want to go from kilocalories per day to kilojoules per day to kilojoules per week, so we can use the conversion 7 days is equal to 1 week. Days cancels, and we'll end up with a unit of kilojoules per week for that. So do that calculation, write down your answer. Now compare these two numbers. Which is greater and by how much is it greater? So to make the question more specific, how many times more gasoline energy do you use than food energy? So take the number you get for weekly gasoline energy, divide by the number for weekly food energy to get a ratio. And that ratio is how many times more energy do you use in gasoline than you do in food that you consume. And then your number, so just to give you some kind of scale, my own personal result was 24. I use 24 times as much energy in gasoline than I do in the food I consume. Your particular ratio will depend on how much you, obviously, how much you drive and how much you eat. But this gives you an idea of one person's specific number.